challenges in PhD studies, and I'm Nick Polydorides. I am the head of the Institute for Digital Comms at Edinburgh. We say overcoming challenges, but you can imagine that I'm gonna touch base on some of those things. Let me also move the bar so I can see what's going on. So before I go down to the challenges, I'd like to set the stage and explain very briefly what my idea of a PhD is. That might be slightly different from what people think, but nonetheless, I think the ingredients of a PhD are essentially four. You need to have a big idea, and note that I've written big idea instead of just an idea. There has to be analysis, implementation, and impact. So everybody who gets a PhD at the end, they will have a combination of these aspects in their PhD study in different ways. Some people will have a stronger idea and a weaker implementation, or more of an analysis on a not so big idea, but nonetheless, these are the four ingredients or constituents, if you like, of a PhD that makes it different from any other venture. So I like to stand on the idea for a little bit, and I write this groundbreaking. It can be a new solution to an old problem if you have something quite radical to offer, or it could be a new problem. You can imagine a new capability or a new concept that will improve the lives of people, then that could probably need to be formulated into a new problem. And I'm writing what makes this idea special is that it had to be high risk, high return, right? And this is the important bit. Why doesn't it have to be high risk? Because you have 3.5 years to try something challenging. If you had 6 months or 1 year, it probably wouldn't be so high risk. But 3.5 years allow you to go deep into the topic and take a few gambles, and at least you want one of them to pay through, and then you have a PhD. But if it's something that the idea is not high risk, is incremental, then immediately puts a lot of weight on the analysis, implementation, and impact, which makes the challenge even bigger for completing a PhD. And at the end of the day, you need to remember that your primary scope here is to contribute to the knowledge, meaning that if you have a high-risk project, then in 3.5 years you provide enough evidence that that problem doesn't have a solution that is equally valuable to solving an actual problem. So you are contributing to knowledge. You're not necessarily putting a product on the table at the end of your PhD. So you have to do some analysis. You have to convince the other why it works, how it works, and when it doesn't, right? And please don't try and come up with justifications where you have a system, a piece of hardware, a piece of software that is applicable to all purpose. So this isn't realistic enough. And if you make such claims, then you haven't done your homework well enough. Let me stay a little bit on the analysis section. I'm using the terms analysis in a fairly loose way. Someone might be doing a software project, or a mathematical project, or a hardware project, physics project. So analysis has to be independent from the validation. So in the analysis, you have to provide evidence based on your knowledge, based on science, why what you're doing should have any chances of working. The analysis is not to use your experimental validation or your software simulation to explain why it works, right? So the analysis, the experiment and the software simulation should come to validate the analysis. They don't come to support the analysis. It's, at least to my opinion, a major trap in doing PhDs. And then you have to do the implementation, right? You do a lot of thinking. Then you have to do some kind of testing of whether these ideas can lead to some engineering concept. And the implementation can also be done in different ways. You can do a fairly professional piece of software or hardware. You can do something that's on a bench. something simplistic or abstract. And this is kind of where now it starts to become interesting, because to my mind, a groundbreaking idea with a simplistic implementation has a much bigger gravity and a higher probability of a PhD success than a fairly risk-free idea on which you do a very professional implementation. So this is something that, I mean, I always advise my PhD students that, doing an okay implementation job on a groundbreaking idea is more valuable than doing a professional job in a simpler idea. And of course, there has to be some impact. If that thing is only of interest to you and your supervisor, then this isn't going to go very far. So you have to publish, you have to see how that piece of work will help you getting employment, will help you start up a new business maybe, or contribute to some other corporate venture. At the end of the day, you got to see the PhD as a 3-4 year investment. I think the people who work on this project, they probably have their wages paid for the project. So the impact that you have to create for your PhD should be at least to be able to pay your bills at the end of your PhD, if that makes sense. So you have to create something. You don't just study endless without having some kind of impact on the outside world. Okay, let me just the slide. Okay, so challenges that come in different formats, and I think probably some of my predecessors have probably touched upon them. So there's kind of a natural anxiety and stress that come from the uncertain. So you're entering into a situation where you got 3.5 years of time in front of you to do a very challenging project, but you haven't got it narrowed down to what you're going to be doing every day. So if you know that you have to do something, but you don't know what to do, then that kind of causes anxiety and stress. So obviously you'll be thinking, is this going to work? Am I going to get a PhD out of this? And if I do, will I be employable? And why would they employ me and not someone else that does optical comms in a different university? These things are natural, and in some level, they're helpful to the process. When they're not helpful is when you do get these anxieties, but you haven't got a pathway, a plan of action to channel them through. And that makes you stuck there and you feel like the pressure of time. So the other challenge, or call them challenges or opportunities in a PhD, if you like, is you have to understand that there is a learning curve. You're not going to producing publishable research from day one. There is a time and there is a trajectory on which you will start become familiar with the topic. Then you go into it, then you start putting down interesting questions, and then you do something else. So there is a learning curve. It's not going to be flat. And you will do much more effort for a smaller reward in the beginning, and then you'll be doing much less effort for a higher reward towards the end of your PhD. For that to happen, though, it's good to have some information on what you need to learn. You need to learn when you go into a PhD in communications. You need to know something about, in this particular case, light transport. You need to know about devices, etc. So what skills do I need? And if I don't have them, which is probably valid for most of people, you need to ask, how do I get them? And these are very practical questions. I mean, nobody would say, just go get them in the library. You need to have a more viable plan on how do you get whatever you need in terms of knowledge to complete. And then obviously literature review, and how much and how do you do it, and what kind of practice. And I think someone else already talked about this. But you need to have a plan. You surely cannot read all the literature that's relevant and then start working, because that's probably isn't going to be a very good idea. Humans do not function like that. And on top of the science, there are also some peripheral skills that you need to have, like how to program in ABC language, or you need to do some experiment. Even if you are doing a computational piece of research, then you should be able to understand at least how the experiment will work. And the other challenge is communication. So part of our business is not just to produce science, it's also to communicate science, tell others what we do. So can we explain what the project is about and explain to different audiences? This is probably a task that I put to my students in the first few months. They have to come up with a fairly short explanation of what their project is about, just so that they can talk to somebody who is not relevant and understand what the project is about. Can you write reports? Surely doing the research isn't going to be enough. You have to write it somewhere. And then can you present to an audience? And again, these are perhaps equally important as actually doing the research yourself, because if you think about it, the purpose of the PhD is to develop new knowledge and pass it on to the society. So if you just develop it but you're not capable of passing it on, then this is probably going to be a wasted effort. Okay, what else do I have? Right. Okay, so overcoming challenges essentially needs a good planning. So you need to be realistic on what is feasible to achieve. And I say this also for students who are pursuing ICT-like projects. And so if you take up to develop an algorithm that will improve the existing state of the art that has 98% chance of success to make it 99% of chance of success, then that will be an improvement, but you got to think whether it is realistic to hit a win in that narrow margin. What will be the cost if you succeed, and what will be the cost if you lose? So you got to be able to aim for things that are risky, but will also have a chance of success. You need to organize your work and time. That is, again, fundamental. By organization, I mean you literally need to have at least a weekly schedule of what needs to happen over the next 6 or 7 months with that kind of resolution. Otherwise, the time will drift. One problem will lead to another more difficult problem, and then you find yourself lost. So you need to be also self-critical. As I said, what is if you go down the road, you need to be explicit as to how are you exactly going to improve what is out there, and see whether this is convincing enough if you're sending across the examiner of the PhD at the end of the process. You're also going to be prepared psychologically, because research is a difficult thing. I mean, that's the nature of the beast. There will be more bad days than good days, and that's because as they're challenging. If you're doing your PhD and every day is easy and straightforward, and you achieve your goals on a daily basis, then you're probably not doing a very challenging PhD. So in most of the cases, there will be a lot of trial and error, but learning out of the process. But there will be 1 or 2 successes, and you don't need to have more than a few successes to score for a PhD. You need to take initiatives on potential directions and methods, meaning that if you stuck somehow, then you won't necessarily wait until your next meeting with your supervisor to see what kind of advice the oracle will give you. You need to take initiatives, look what other people are doing, what they're publishing, and suggest potential directions. Put a few things on the table as to how you can overcome the problem. And you also need to network. I mean, that's some of the challenges, for example, employment or dissemination, can also be overcome by networking, which is important, not just for PhD students, also postdocs and academics ourselves. So there's so many people now working on a particular problem, optical comms, for example, like thousands of people. So unless you kind of connect with people that do similar stuff, then you're probably going to be isolated, and you won't take advantage of the good things that come with networking, joint publications, conferences, recognition, that kind of thing. Okay, this is my final slide. Probably have a few more minutes and I'll let you go. So at some point through your PhD, there comes a realization that most of the time will be spent on reading, comprehension, and writing. And these are three different things. You'll be doing a lot of reading, a fair amount of comprehension, meaning like you try to understand what you just read, and you're doing much less writing because of, probably you write a few reports, some papers, and the mighty thesis at the end. But by comparison, if you think of a 3.5-year PhD tenure, you're doing more reading than writing. And the one thing, the bad news though, is that the reading is easy, right? And writing is difficult. And there has to be a realization of this thing early on. So nobody is skilled on writing about science. Nobody gets born like that. So you need to practice. And you need to practice as soon as you realize that you might be reading 2 or 3 papers per day and maybe understanding them. But to write an abstract could take you a week to do the first draft. So this is something that is becoming increasingly important and imperative, because if you cannot write to a technical audience, then there isn't going to be a PhD. I mean, nobody will write your PhD, even if you have done a miracle of science. Nobody's going to write the PhD for you. So there is a way to go about it. I'm sure there are training courses, at least the University of Edinburgh provides dedicated courses on writing technical papers and writing abstracts. You need to be effective on how do you do your literature review, and how do you read the paper, how do you summarize the contents of the paper. And you gotta be, at the end of the day, you need practice in writing papers, conference papers, journal papers, and also reviewing, because you got to see the process from both ways. You see what the reviewers are picking up in the writing style, whether there's enough clarity, whether the author can articulate what they want to say with 2 sentences instead of 20, and so on. So this is an often forgotten aspect of the PhD, where students are just rushing into doing the code, they do the nice simulation, they do the nice experiment, and then they're daunted by the task of writing the whole thing up. And this kind of brings the morale down. So it's good to start early and try and attempt to write something just so that you pick up the process. And of course, you can share experiences with your peers. You learn how they write, you learn how they read. You can just understand why that particular way works for them. And something similar can work for you as well.